Hi, for this video, we'll be looking at the summary for Chapter 3B on transformations of graphs. Right, the first part of the chapter deals with these three basic types of transformation of graphs, namely translation, scaling, and reflection. And each of these three can be done parallel or about the x-axis or parallel or about the y-axis. All right, let's run through the concepts for them. Okay, suppose I have a graph y equals to fx, all right? And if I were to transform the expression, all right, of the equation, all right, the fx part, letting the x become x plus 2, okay? So that would actually then transform to this new graph, okay? What's the transformation steps involved? Okay, there will be a translation, all right? We'll be actually translating the graph 2 units. Okay, here you're seeing x becoming x plus. In the more usual sense, we may think that it's translating in the positive x direction, but actually things would be opposite way. It will be a translation of 2 units in the not positive but negative x direction. Is that all right? Okay, so that means the graph will undergo a shifting 2 units to the left. Okay, because it's in the negative x direction. Okay, and to phrase the description for translation, this is what you should write. All right, translate how many units in positive or negative x direction, or direction with a hyphen. All right, so please know this standard phrasing. So suppose class my fx is this graph, or x squared x plus 2. Okay, so the new equation, the graph that's been shifted kind of left by 2 units, will take this form, the x becoming x plus 2, okay? And then this one also becoming x plus 2, so x plus 2 plus 2 plus 4, all right? So it becomes this equation. Okay, the original fx graph looks like this. Okay, it's a cubic graph. So the roots will be at -2 and 0. All right, 0 is a repeated root. So actually it goes like that, all right? Okay, here we see that if I substitute 1 into the equation, okay, I get what? 1 times 3, right? So there's a 0.13 on the curve. So let's understand why is there a reversed relationship, or when we see plus here, actually it's shifting left but not right, okay? Reason being this, it has to be this graph here. Imagine everything shifted by 2 units, so this point comes here, all right? And I will have a point that runs through this point, shifted left by 2 units, will get to the value -13, isn't it? Okay, let's understand why. Because previously, when I substitute 1 into the original fx equation, my output is 3. So now imagine in this new equation, where all the x becoming x plus 2, okay, I have to actually substitute -1, isn't it? To achieve the same output. Now imagine this -1, then this overall will be 1. Alright, and if x is -1, here will be 1. Sorry, this should be 2. Okay. So it will be 1 plus 2, which is 3. So it will still give the same output 3. So that means I need a smaller value by 2 units than 1 to sub into the new equation to get the same output 3. Alright, so that's actually the reason of why there is a kind of like reversal effect. Alright, needing the lesser value in x to produce the same effect as the original x value. Alright, so roughly you know that. But ultimately, if you were to remember this transformation step we'll do, we'll see x becoming x plus 2 is a translation in the negative x direction. Okay, how about the other two transformation respect to the x-axis? All right, let's look at scaling. Scaling will be happening when the x becomes a multiple of the x, let's say becoming 2x. Okay, so I'm getting this new graph, f2x. All right, so that will be a scaling, or I will scale the graph by factor. Same thing, the reversal effect. If you see 2 here, doesn't mean factor 2, but rather factor half. All right, we scale the graph by factor half parallel to x-axis. Okay, so meaning if the original graph is like that, all right, then all the x value will be multiplied by half. Or let's say there's a point here, original x value is a, then the new graph, the x value will become a over 2. All right, so everything will be compressed times 2 to the x value. So the new graph will be more compressed in this manner. Is it okay? Kind of like string by half width. Okay, so that's what scaling means. Okay, then finally on reflection. Reflection is a bit like scaling, but the scale kind of this value becomes -1. All right, so when x becomes negative x, okay, I'm actually having this new curve here, okay, with all the x becoming negative x. So that will achieve what transformation effect? It will be a reflection, or we will have reflect the graph about the y-axis. I'll be careful, not x-axis here. Because it's the x value becoming negative x. So suppose my graph is this, all right? So there is the point here, okay, AB. So now the new graph will have a point negative AB. So the x value will become negative x, all right? And if there's a point here, it will come here. So that's why it's a reflection, not about the x-axis but about the y-axis. Is it okay? There's a reflection in this manner. Y-axis like is your kind of middle mirror line. Okay, so this one be careful. All right, should be y here. Okay, but it's actually the x becoming negative x. All right, so it's still happening kind of like parallel to the x-axis, but the overall effect is a reflection about the y-axis. Okay, so if we go by this principle, so should the now the variable that's changed is the y, also y becoming y plus 2. Okay, the principle should be the same. So we'll be dealing with a translation of 2 units in the not positive but negative y direction. Okay, but when we learn this topic, right, there seems to be a difference if it's with the x or y direction, but actually the principle should stay the same. When you see a plus 2, it is still in the negative direction. But why do we have the impression that it's different? Because you see, when we do this transformation, it's actually this y becoming y plus 2. But we like to write the equation with y being the subject. So it seems that when we shift the plus x over to the right hand side, then it looks like minus 2. So we think that actually it's like minus matching negative. That's not true. Okay, it should still be the same principle. It's y becoming y plus 2, so that's why it's in the negative y direction. Or the transformation principle should not be different from that of the x variable. Okay? Alright, so then with the other two, with regards to the y variable, if fx, y equals fx becoming, when y becoming negative y, meaning when it becomes negative fx, okay, sorry, I've jumped step, or I've gone to the reflection, so this will be a reflection about the x-axis instead, okay, matching this one. Alright, then finally on the scaling, when y becoming, say, 2y, okay, y becoming 2y, so I will get this equation of y equals to half fx. That's a scaling by factor half parallel to the y-axis. Okay, so these are the important things to take note, all right, for transformations of graphs. What we do with the x variable should be the same as how it goes with the y variable. All right, but of course, question can be more complicated with a mixture of a few steps. Okay, so we'll talk more in the tutorial. Okay, the second part of this topic is on sketching the graph of this view. Y equals to modulus fx, f of the modulus of x, and 1 over fx. All right, so in our syllabus, we also have graphs of this sketch based on y equals to fx. So what happens with the graph of y equals to fx when we modulus the fx, when we modulus the x, or when we do the reciprocal 1 over? Okay, so that's also the skills that you need to know. Okay, for modulus fx is very easy. Okay, suppose this is our graph. Okay, if suppose this is fx, all right, and if you modulus the fx, right, class what you do is you keep all the parts of the curve above the x-axis, and those that is below the x-axis, or this portion and this one, the green one, you just flip it above. Is it okay? So the overall answer will be this one here, this part, and this one. So this is my y equals to modulus x, all very easy. So negative y portion flip up or to become reflect about the x-axis to go to the top, all right? For the modulus of x graph, okay, suppose this is my graph, all right? Suppose this is fx, y equals to fx. So what we do class will be to keep the right hand side or the right of the x-axis, sorry, the right of the y-axis, okay, keep everything, remove, okay, the whatever's on the left, and then duplicate the right to the left. Right, so let me erase this one. So what you see on the right now, you duplicate to the left. And for such graph, right, it is possible to get sharp pointed edges like that, because previously this part of the graph, is still rising, and if you suddenly erase it, it's really having a going up gradient, and with the reflection, you might get a sharp point. Okay, so it's perfectly fine. Sharp points on the y-axis. Okay, possible. So this would be the f modulus x graph. All right, so that would be the transformation step. As for this 1 over fx graph, is basically this. Previously, the fx is the oy value. So the new graph, the new y value is equals to 1 over the oy value. All right. So suppose my graph is this way, having a maximum point at a5. So in the new graph, when x is a, okay, the new y value should be 1 over the oy value. So at a, I should have on the new graph a point a1 over 5. Is it okay? The y value becoming 1 over y. Yeah, so if you go by this logic, 5 is the highest amongst this vicinity. Also, maybe I have a point 4 here, or something 4. So it will become 1/4. So a lower point becomes a higher point for the new graph. So things goes opposite, that's all. And if the y value is positive, with it becoming 1 over y, it still stays positive. That's also another insight for the 1 over fx graph. That if a graph, if in a certain segment of x that I'm looking at, if the graph is above the x-axis, the new graph is still above the x-axis. All right. Vice versa. If the graph is originally having negative y value, the new graph also will be below the x-axis. All right. Just that the y values are becoming 1 over. Okay, we'll talk more about the 1 over fx graph when we go through the tutorial questions. All right, so that's the scope for this chapter 3B on transformations of graphs. Thank you.